Imagine a hero, not with a whip and fedora but with a mind for discovery and a heart set on unraveling the mysteries of the cosmos. This hero doesn't swing from vines or chase after lost relics. Instead, it floats silently in the cold, endless expanse of space, its gaze fixed on the most distant corners of the universe. Armed with a giant golden mirror, this explorer is on a quest to uncover the ancient tombs of stars, those cosmic graveyards where the secrets of creation are buried. Its mission is not just to look, but to see what no one has ever seen before: the birth of the first galaxies, the glow of the earliest stars, and the hidden wonders that have shaped everything we know. This hero is the James Webb Space Telescope, our cosmic archaeologist. With its powerful eyes, it peers deep into the past, reaching back over 13 billion years to uncover the story of our universe. Webb is not just a telescope, it's a time traveler, a storyteller, and a bridge to the unknown. Webb is a time machine, catching faint, ancient light that's traveled billions of years to reach us. Each photon it captures is a message from a time when the universe was young, when galaxies were just beginning to form, and when the building blocks of life were being forged in the hearts of stars. For the first time, we can peer through the thick clouds of dust at the heart of our own galaxy, the Milky Way. Webb's infrared vision reveals what was once hidden: the swirling nurseries where stars are born, the remnants of ancient supernovae, and the intricate dance of matter and energy that has shaped our galactic home for billions of years. Understanding the Milky Way's history is about understanding our own origins. Every atom in our bodies was forged in stars that lived and died here, scattering their elements across space. By studying these cosmic cycles, Webb helps us trace the journey of matter from the hearts of stars to the cells in our bodies, a story billions of years in the making. The universe is telling its story, and Webb is our translator. With every image and every spectrum, it brings us closer to understanding where we come from, what we're made of, and what wonders still await us among the stars. Cosmic archaeology is like digging through time, not dirt. Instead of shovels, we use telescopes. Webb is the most powerful yet. By looking farther, we see further back, uncovering the universe's earliest moments. Webb can sort stars in our galaxy by age, finding the oldest fossils from when the Milky Way was young. These ancient stars are like tree rings holding memories of our galaxy's formation. Now we can build a timeline, watching galaxies grow, collide, and change. We're not just spectators, we're piecing together the epic saga of the cosmos, one ancient star at a time. Deep within the heart of our Milky Way galaxy lies a mysterious and densely packed region known as the galactic bulge. For centuries, this core has been shrouded in mystery, hidden from our view by thick clouds of cosmic dust and gas. Astronomers have long wondered what secrets might be concealed in this chaotic, crowded center, where stars are packed together far more tightly than in our own corner of the galaxy. Thanks to the James Webb Space Telescope's powerful infrared vision, we can now peer through the dust and see what was once invisible. Webb has unlocked a true treasure chest, revealing a vast population of ancient stars, many of them surprisingly metal-poor, meaning they formed in the earliest days of the universe, before heavier elements were common. These remarkable stars are more than 12 billion years old, making them some of the oldest objects in our galaxy. They move together in elongated, looping orbits, tracing paths that are relics from the dawn of time, when the Milky Way was just beginning to take shape. Discovering these ancient stars is like stumbling upon the ruins of a lost civilization hidden within a bustling modern city. Their presence offers a rare glimpse into the galaxy's earliest history, preserved right in the midst of the present-day Milky Way. This discovery challenges the long-held belief that our galaxy formed slowly and peacefully over billions of years. Instead, it suggests a far more dramatic and tumultuous past, filled with cosmic upheaval and rapid change. The evidence points to a galaxy built through a series of violent, chaotic events, collisions, mergers, and bursts of star formation that shaped the Milky Way into what we see today. Over billions of years, the Milky Way grew by consuming smaller galaxies, absorbing their stars and gas, and weaving them into its own structure. The ancient stars at its core are living fossils, silent witnesses to the galaxy's dramatic and ever-changing history. How does Webb see what Hubble couldn't? The secret is infrared light. Infrared pierces the thick dust at our galaxy's center, revealing what visible light cannot. It's like seeing through fog with special goggles. Webb's detectors catch the faint heat of ancient stars. This technology finally lets us study the crowded heart of the Milky Way. Without infrared, these ancient stars would remain hidden forever. Now, the fog has lifted, and the view is spectacular. Webb's discovery of ancient stars tells a new story, one of galactic cannibalism. The Milky Way grew by devouring smaller galaxies, assembling itself from their stars and gas. The ancient group Webb found is likely the remnant core of a galaxy consumed over 12 billion years ago. This process continues today as the Milky Way slowly absorbs dwarf galaxies like Sagittarius. By studying these mergers, we reconstruct our galaxy's dramatic construction history. Galaxies are dynamic, evolving systems, constantly colliding, creating, and transforming. The Milky Way story is one of destruction and rebirth, shaping the galaxy we call home. Why does this matter? Why do we look up at the night sky and feel a sense of wonder, a pull toward the stars? The answer is more profound than we might imagine, because we are part of this cosmic story. Our existence is woven into the fabric of the universe itself. When we gaze at the stars, we are in a sense looking at our own origins. Every element in our bodies, carbon, oxygen, iron, was forged in stars, in the hearts of ancient suns that lived and died long before our solar system was born. These stars exploded, scattering their enriched material across the galaxy. Some of these elements originated right here in the Milky Way, in clouds of gas and dust that would one day become our home. Others came from distant galaxies, brought here as the Milky Way collided and merged with its neighbors, consuming them and mixing their stars and elements into its own. The James Webb Space Telescope allows us to trace this incredible journey. Its discoveries reach back billions of years, revealing how the atoms that make up our bodies traveled through space and time, connecting us to the very beginning of the universe. We live in a galaxy with a rich, dramatic history, a history that made us possible. The Milky Way is not just our home, it is our ancestor, shaping the conditions for life as we know it. The atoms in us have traveled through exploding stars and colliding galaxies, journeying across unimaginable distances and epochs before coming together to form life on Earth. Thanks to Webb, we understand our origins better than ever before. We can now see the cosmic threads that connect us to the universe and appreciate the incredible story written in our very atoms. The cosmos is calling, inviting us to explore, to question, and to marvel. And for the first time, we're truly beginning to understand its answer, a story that is, in every sense, our own.